In this video, we're going to look at rationalizing. We're actually going to look at using conjugates. In this one, not so much. We've got 9 divided by root 3. It's an irrational fraction. So what we want to do is we want to rationalize it. So we've got 9 over root 3. So what we're going to do is we're going to multiply that by root 3 over root 3. And the reason why we're going to do that is we're multiplying it by 1. When we multiply something by 1, we're not changing it. It's still itself. So we can go from there to solve the question. So 9 times root 3 is 9 root 3. Root 3 times root 3 is 3. And then 3 and the 9, well, they cancel out. And we're left with 3 root 3. And we've rationalized that fraction. Okay, so if we had a question such as root 3 over 1 take root 3, we'd have to rationalize it, but what we use is its conjugate. So we've multiplied the other one by root 3. In this one, we're going to multiply by 1 plus root 3 over 1 plus root 3. Now, the reason why is because it turns into a difference of 2 squares, so we eliminate the surd when we multiply through. And we're multiplying by 1, so technically we're not changing it, we're multiplying it by 1, so nothing's going to happen. So what we do is we expand, so we get root 3 times 1 is root 3, root 3 times 3 is that's 3. And what we're trying to do is we want it in this form, we want a plus b root 3, where a and b are integers. So we've got root 3 plus root, and now what we have, because we know we've got 1 take root 3 and 1 plus root 3, that's a perfect square. So it's just, we're going to come 1 take 3. When we expand, because it's 1 squared, which is 1, take root 3 squared, which is 3. So we're left with 3 plus root 3 over negative 2, which equals negative 3 over 2 take root 3 over 2. So in this case, a is equal to negative 3 on 2 and b is equal to negative a half. Because there's nothing in front of the root 3, so that's just 1. Just like if we've got x, that's 1x. It's the same type of thing. It's very similar.